Hi Hires, welcome to lesson 3 of the YouTube clips. Today we're going to talk about ionization energy. Now usually I would have a starter, but I feel like we've done tons of atomic size, covalent radius, ionic radius questions, so we're just going to get straight into it. Okay, so first things first, we need to know what ionization energy is. Okay, now we're going to talk about the first ionization energy. Okay, and what we mean by that, it's the energy required to remove, and this is important, 1 mole of electrons from 1 mole of atoms in the gaseous state. Okay, now very much like homologous series, isomers, isotopes, even covalent radius that we learned to do with atomic size, we need to know this definition. Okay, now there are important parts to this. So it's the energy required, you have to say, to remove 1 mole of electrons from 1 mole of atoms in the gaseous state. Okay, a lot of people just say the energy required to remove electrons. This is higher, you wouldn't get that. You wouldn't get the mark for that. You have to say the energy required to remove 1 mole of electrons from 1 mole of atoms in the gaseous state. Now, what we mean by that, I'll give you a wee example. We'll go for potassium. Okay, now what we do, potassium's got the symbol K, and because it's a gaseous state, we have to put that symbol in. Okay, that symbol is so important when you're writing out the equations. If you don't have that symbol, you lose a mark. Okay, so potassium in the gaseous state, we lose an electron, and if we lose an electron, that goes to K plus, and again it's in the gaseous state. Okay, so we went from the atom to the ion, and obviously we've lost an electron, so yeah, we get that. Now again, very important, that we put the gaseous symbol in. If we don't, you do lose a mark. Okay, now what I'm going to show you now is the data book. So this is page 11. Yeah, now if we look for potassium, okay, there it is there. The first ionization energy of potassium is 419. Yeah, so what we would put is we would put delta H equals plus 418 kilojoules per mole. Now that delta H is just a change in enthalpy. We will talk a wee bit more about that in the future. Don't worry about it too much, but we will come back to it. And then kilojoules per mole, that's the energy. Okay, so to remove 1 electron from potassium in the gaseous state, we need 419 kilojoules of energy per 1 mole of potassium. Okay, now also want to draw your attention to this here. Okay, it's positive. Now what this means, this symbol here, positive, means it's endothermic. Okay, and you should know from National 5 that endothermic means energy is taken in. Okay, and that makes sense. Yeah, Why is it endothermic? Because energy is required to remove the electron. Okay, so wee question here. Why is ionization energy an endothermic process? Okay, and quite simply the answer, as energy is required to remove the electrons. Yeah, you think of an atom. If we want to take away one of the atom's electrons, we're going to need to put in energy. Yeah, makes sense. Makes sense. Right, so let's go for a wee example. Okay, we'll do it together, and I'll give you one to do, and I'll come back to it at the end, hopefully, if I remember. So chlorine. Again, what's the symbol for chlorine? Cl, and remember, it's in the gaseous state. Okay, if that goes for the first ionization energy, we're removing 1 mole of electrons from 1 mole of atoms in the gaseous state. So that chlorine goes to Cl plus G plus E minus. Now, we've never seen chlorine with a positive charge before. Usually we have it so it's negative. Okay, so just be careful when you're doing ionization energy. We are creating a positive ion. Okay, so, and if I go to back to the data book, page 11, okay, where it gives us ionization energy. If we try and look for chlorine, there it is. What's the first ionization of chlorine? 1251. Okay, so what we put is delta H equals 1251, and then what's important? You put that wee plus in. Yeah, and that tells us it's endothermic because we've removed an electron. And then the units, kilojoules per mole. Okay, so what I want you guys to do is do sodium, and I also want you to do oxygen. Okay, so what you'll need to do is pause this video, fill it out, and then carry on, and then hopefully if I should remember, I'll come back to it and I'll give you the answer. Right, so what we're going to look at now is we're going to look at the trends. Yeah, we're going to look at the trends going across a period and then the trends going down a group. So as we go along a period, the ionization energy, just going to put a blank there, okay, as we go down a group, the ionization energy again, we're going to put a blank there. Right, so we'll do the period first. Okay, so we'll go for period 2, so that's lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. That's going across the way. Yeah, if I just get the periodic table out, so lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So if we look at that, what's happening to the first what's happening to the first ionization energy? 520, 900, 801, 1086, 1402, 1314, 1681, 2081. Generally, the ionization energy is increasing. Okay, now I know there's a few discrepancies, but on the whole, the ionization energy does increase as we go across the period. So add that. So as we go along the period, the ionization energy increases. Okay, now as we go down a group, what happens to the ionization energy? So we'll start with group 1. So we'll go for lithium, sodium, potassium, rubidium, cesium. Okay, so lithium 520, sodium 496, potassium 419, rubidium 403, cesium 376. So you should see that each time we go down a group, the ionization energy decreases. Okay, and you need to know those two trends. Now, that's, to be honest, that's quite easy because you can just look at a data book and it tells you that. What we're interested in higher is why, as we go along the period, it increases. Why, as we go down a group, it decreases. Okay, and that's what we're going to go under. That's what we're going to start. So, explanations. And again, you actually already know this. Okay, so we're going to start as we go along a period. Okay, remember, write that wee statement, get your bullet points in. So as we go along the period, what do? We add a proton. Okay, a proton is added. Now, what does that proton do? If we add a proton, that creates a stronger, and again the key word, positive nuclear charge. Okay, now if we create a stronger positive nuclear charge, what does that do? It pulls outer electrons, outer electrons closer to nucleus. Okay, now we've done that plenty of times. There's our 3 P's: proton, positive, pulls. You have to get each of these statements in. I love a bullet point. It makes it so clear. It's easy for the marker to mark. That's what I would recommend doing. Bullet point it. Now, because it's ionization energy, we have to change it just ever so slightly, and we do that with a 4th bullet point. Okay, so a proton's added, creates a stronger positive nuclear charge, and that pulls the outer electrons closer to the nucleus. Now, if the outer electrons are closer to the nucleus, what does that mean? That means it's harder to remove an electron. Okay, so we have to say that. It's harder to remove an outer electron. Okay, and if it's harder to remove an outer electron, in order to remove that, we need to put more energy into it. So what increases? The ionization energy. Okay, so ionization energy increases. Okay, and that's it. That's how you answer it. So we've basically just been writing what we've been writing all this time, but we've added this new line in, so it's harder to remove an outer electron. Boom, done. Easy. Now, as we go down, a group, what happens? Well, an extra energy level is added each time. Okay, now remember, as we're talking about going down the group, you have to be specific. So an extra energy level is added each time. If we're talking about lithium and potassium, 2 energy levels have been added. So just again, be careful, make sure you are being very specific each time. Right, so an extra energy level is added each time. What does that mean? Well, the extra inner energy levels, what do they create? They create a shielding effect. Yeah, well, they create a stronger shielding effect. And what does that shielding effect do? It weakens the force of attraction, okay, which weakens the force of attraction. Now you can't just say it weakens the force of attraction. What does it weaken the force of attraction of? You need to say that, okay? So, wait there. I need to add which weakens in there, which weakens the force of attraction between nucleus and outer electrons. Okay, now again, that's what we've written every single time. Okay, an extra energy level is added each time. Okay, the inner energy levels create a shielding effect, and then that weakens the force of attraction between nucleus and outer electrons. Okay, that's not changed. Yeah, however, because it's ionization energy, we need to add one wee line. Okay, so if an extra energy level is added each time, the outer electrons are further away from the nucleus. The nucleus has a weaker force of attraction, so that means it's easier to remove outer electron. Yeah, so if it's easier to remove the outer electron, that means we need to put less energy in. And if we put less energy in, what does that mean? It means ionization energy decreases. Yeah, and that's it. We've already been through all of this. The only thing that's changing is that tiny last wee line at the end. Is it harder to remove an outer electron, or is it easier to remove an outer electron? Make sure you say that. Don't take shortcuts. Make sure you write every single point. This is higher chemistry. You need to go into detail. Okay? Perfect. Right, now, what we're going to do now, we're going to go for second, third, fourth, etc. ionization energies. Okay, now we're going to kind of bring it full circle, because we're going to start back. We started with potassium, we're going to do potassium again. Okay, now the first, I'm just going to put a wee shorthand here. Okay, so first ionization energy for potassium. Okay, remember potassium's K, and it goes to K plus. Now, have a wee think, what have I forgotten to write? Remember, our definition is energy required to remove 1 mole of electrons from 1 mole of atoms in the gaseous state. So, remember your state symbols, please. Yeah, you will lose a mark if you don't include them, and obviously you need to have your electron. Now the good thing about this equation, yeah, if you have an absolute blank in a test or the exam, if you turn to page 11 in the data booklet, yeah, the ionization page, it tells you the first ionization energy for an element refers to the reaction Eg goes to E plus G plus E minus. So there's no excuse to forget that. Now, if we go for the second ionization energy, yeah, where we take a second electron. Now, we have that. Okay, so after the first ionization energy, we have that. So in the second ionization energy, that's what we start with. Okay, because an electron's already been removed, so we start there. Yeah, we start there. Now, remember, how many electrons are we removing? Think back to your definition. We're removing 1 mole. Okay, so K plus will go to K2 plus G plus an electron. Okay, now if we go for the third ionization energy, so we've now got K2 plus. We start with K2 plus, and again remember your G. And then what would K2 plus go to? That would go to K3 plus an electron. Okay, and that would keep on going. Okay, your second, your third, your fourth, fifth, sixth, seventh, eighth, ninth. It would keep on going until you've ran out of electrons. Okay, now what do I mean by that? Let's do lithium. Okay, lithium has an electron arrangement of 2, 1. Yeah, it's got an atomic number of 3, 2 in the first shell, 1 in the second shell. So if we go through the first ionization energy of lithium, that goes to Lig, that goes to Li plus G plus E minus. Now, if we've removed an electron, what that goes to, lithium now goes to an electron arrangement of 2. Yeah? Now, if we do a second ionization energy, we start with Li plus G, and that goes to Li2 plus G, because we've removed an electron. Now, if we've removed an electron, that electron arrangement is now 1. So Li2 plus only has 1 electron. With me so far? Okay. Now, if we go for the third ionization energy, Li2 plus goes to Li3 plus. Again, don't forget your G's, please. Plus an electron. Now, if we remove an electron, Li3 plus now has no electrons. Okay, so we can't remove an electron if there's no electron. So the fourth ionization of lithium does not exist, as there are no more electrons left to remove. And that there, if you look at this page here, that's why you've got values for the first, the second, the third, but you don't have a value for the fourth. Now that's quite a common past paper question. Why does lithium not have a fourth ionization energy? And you need to realise it's because, well, lithium's only got 3 electrons, so it can only go through 3. Now helium's only got 2 electrons, so it only has 2 ionization energies. Hydrogen only has 1 electron, so it only has 1 ionization energy. Okay, I hope that makes sense. Right. Let's actually go back to this here. So lithium, the first ionization is 520. Okay, so that's the first. So delta H equals 520 kilojoules per mole. And remember, ionization energy, we're putting energy in, so it's endothermic, so we need a positive symbol there. Okay, now the second ionization energy of lithium, where am I? Here, 520. The second is 7,298. Okay, so the second one would be delta H equals positive 7,298 kilojoules per mole. Okay, and then the third one is 11,815. Okay, so again, delta H equals positive 11,815 kilojoules per mole. Okay, does that make sense? Obviously, if it doesn't, you email me, send me a wee message on Teams, rewatch the video, but I hope it should. It's pretty straightforward, but again, if you are unsure, please contact me, because it is going to get just a wee bit harder now. And then I think we'll probably stop there, because I don't want to overload you with all this new information. Okay, now, typical question would be, how much energy is required for let's go for Lig to Li3 plus G plus 3 electrons. Now, this is where it gets a wee bit trickier. So we're starting with Li and we're going all the way to Li3 plus. So how many ionization energies have we went through now? If we look through this, Li to Li plus, that's 1. Li plus to Li2 plus, that's 2. Li2 plus to Li3 plus, yeah, that's our target. Okay, so in order to go from there to there, we need to add that value to that value to that value. Okay, so delta H would be 520 add 7,298 plus 11,815. Now, I don't actually have this value in the top of my head, so let me just very quickly put this in to a calculator. You guys can do the same, make sure I'm right, because you never know, I might be making a deliberate mistake for you guys to notice. So should be 19,633 kilojoules per mole. Now if I'm wrong, just let me know. Okay, so that typical exam type question, however it can get just that wee bit harder. Okay, and this is the type of question that they like to fling in because of the SQA. They're horrible people. Yeah, they're trying to trick you, so it's up to us to not fall for that. Now they might ask you for this. Okay, so we're going from Li plus, we're losing 2 electrons and we're getting Li3 plus, and again we're in the gaseous state. So this is where it gets a wee bit tricky, and for this I'm going to use the marking. So we're at Li plus, okay, so we are starting here, yeah. Now the first ionization energy has already happened, okay, so because it's already happened, we do not need to include that value, okay. Now where are we ending up? Li plus, we're going to Li3 plus, so that's our target. Now how do we get from there to there? We need to add that and that together, okay. A lot of people that add that in as well, and you have to make sure you don't fall for it, okay. So make sure you're starting here, you add that to that. So what we have is delta H equals 7298 add 11,815, and again I don't have this on top of my head, so if I do this in a calculator very quickly, we get plus 19,113 kilojoules per mole, and that's your answer, okay. So make sure you know how to do these questions, very very important, okay. Right, what we're going to do is we're going to do some questions to try, okay. So this is for you guys, I want you to be doing these questions. So what is the definition of the first ionization energy? Okay, that's the very first one. Question 2, why is this process endothermic? Yeah, now obviously you could just look back and get those answers. Try to do it with the top of your head, see if you can work it out first, and then if you can't, then use your notes, okay. Question 3, let me how does the first ionization energy of sodium compare I'm going to change that. How does the first ionization energy of chlorine compare with that of sodium? No. Yes, sorry. And then I want you to, now this is the important part, I want you to explain. Yeah, so don't just tell me that chlorine is smaller or chlorine is bigger. Yeah, that's great, you can use your data book for that. I want you to explain why chlorine is smaller, why chlorine is bigger, okay. I'm leaving a gap so that I can put my answer. I'll take a picture and then I'll put it up in Teams. Right, so how does the first, I'm just going to write IE for this, how does the first ionization energy of, let me look at my data book. How does the first ionization energy of fluorine compare with that of bromine? Yeah, and again, the important part is explain your answer. Okay, so tell me what one has the bigger or what one has the smaller ionization energy, and then tell me why that's the case. Okay, so important that you explain why. Question 5, I want you to work out delta H of the following. Okay, so I'm going to give you 3. Let me see what I'm going to give you. Give you that one, nice wee easy one to start with. Step up just ever so slightly. And then I want you to work out, let's go for this one. Al plus going to Al let's go for that actually. Okay, so Be in the gaseous state going to Be plus in the gaseous state plus an electron. Then I want you to work out phosphorus in the gaseous state going to phosphorus 2 plus in the gaseous state plus 2 electrons, and then aluminium plus in the gaseous state going to aluminium 4 plus in the gaseous state plus 3 electrons. Okay, so be careful with question C. We are starting with plus. Okay, so what does that mean? Have a wee think. Right, I'm happy with that. I'll leave that there. Thank you.